Okay, so we're going to prove by the principle of mathematical induction that 2 to the n is bigger than n squared for all n bigger than 4. So let's go ahead and start this proof. Okay, so let's do our base step. Consider s of 5, right? So we'll consider the statement for 5. So this is saying that 2 to the 5 is bigger than 5 squared. Well, 2 to the 5 is 32, and 5 squared is 25, so that does fit, right? So at least for n equals 5, the statement is true. Let's go ahead and move on to our induction step. Okay, so we're going to suppose s of k is true for some k contained in the natural numbers where k is bigger than 4, right? So this implies that, let's have our statement. This implies that 2 to the k is bigger than k squared, right? For k bigger than 4. All right. So now let us consider, because we want to, assuming that the statement involving k is true, we want to prove that the statement involving the next integer is true, aka k plus 1. So let's go ahead and consider 2 to the k plus 1, right? Remember, we want to prove that 2 to the k plus 1 is bigger than k plus 1 squared. So I'm going to have k plus 1 squared down here somewhere, right? So k plus 1 squared, right? Let me move this a little bit. All right. So we know 2 to the k plus 1 is the same thing as 2 times 2 to the k, right? And from our induction hypothesis, I know that 2 to the k is bigger than k squared. So this is bigger than 2 times k squared, right? So now I have 2k squared. Now I'm going to try to connect this with this, right? So I know k plus 1 squared is the same thing as k squared plus 2k plus 1. Well, I have a k squared by itself, so at least over here, I can put this as equal to k squared plus k squared. So I have that k squared here, but I do sort of know that for k bigger than 4, that k squared is bigger than 2k plus 1. So for a k bigger than 4, I know that k squared is bigger than 2k plus 1, right? So I know that this here is bigger than this. Because if you were to plug in 5, 5 squared is 25, 2 times 5 is 10, plus 1 is 11. So I know, at least for k bigger than 4, that k squared is bigger than 2k plus 1, which is what I needed to get my k plus 1 squared to show. So this shows that 2 to the k plus 1 is bigger than k plus 1 squared. For k bigger than 4. So this implies that the statement involving k plus 1 is true. So assuming the statement for k was true, we were able to show that the statement for k plus 1 is true. Therefore, by the principle of mathematical induction, for every n contained in the natural numbers, where n is bigger than 4, we have s of n is true. AKA, we've shown that 2 to the n is bigger than n squared for all n bigger than 4. And that is our proof.